This video is going to look at an example from your homework, number 11 on page 421. The problem starts off 4x squared plus 3y squared equals 48. And if you notice, the coefficients of the x squared and the y squared are not the same, which means that when we divide by 48, which you'll want to do to get this into the format of an ellipse, the a and the b won't be the same. You get x squared over 12 plus y squared over 16 is equal to 1. This matches the equation that we did in class of x minus h squared over b squared plus y minus k squared over a squared is equal to 1. So this is our graphing form. Step B asks which direction is it going. The larger number is under the y, which means that this is going to be a vertical. Step C then asks for the vertex. H and k in this case are 0. And now we can start looking at the graph. At this point, I would want you to start plotting points onto an axis. Make sure you're using your own graph paper, and that's good graph paper. I want to put a point at 0, 0. And then we take a break, and we figure out what's little a, little b, and little c. Well, little a is the square root of 16. I should put equals. A equals b equals c equals. Little a is equal to 4. Little b is equal to the square root of 12, which is 2 radical 3, but we also want an approximate value. So let's open up the graphing calculator. 2 radical 3 is equal to 3.5, or about 3.5. Little c, we need to use a squared equals b squared plus c squared, which is the equation you use for an ellipse when relating a, b, and c. A squared is 16, b squared is 12, which would make c squared equal to 4, or c equal to 2. Now that we've got these three distances, we're going to take the a value. It's a vertical, so you want to go up 4 and down 4 and put points. We're going to go left 3.5 and right 3.5. And then for the c, you're going to want to go the same direction as the vertices, up and down 2. Now all that's left is making sure that we define our foci. Our foci are those red points we just put up to and down to, so 0 plus or minus 2. E is the length of the major. The major axis is this length here, so that would be 8. Minor axis is the length from M to M. So if we're going to do 2 times b, that's really 4 times radical 3, or about 7. All that's left is to try to draw the most perfect ellipse you possibly can, and this isn't going to work because my tablet likes to click into the exact grid point, so we're just going to sketch this one. And there you go.